after the transportation problem, we are going to start with linear programming. And today we'll learn about the basic concepts, and then we'll model two problems, because in the management science problems, there is either to maximize the objective function or minimize. So in this linear programming problems, we'll learn both the types, to maximize and to minimize. Okay, before I start, let me just check, is my voice clear on your side, and you can see the screen properly? And please answer on.
Yes, doctor.
Okay, good. All right. So we can start now, inshallah. I mean, it's already 10:05, so we don't need to wait for others now. Now, the concept of linear programming will look much easier to you, because you have already done transportation, and we learned that transportation problem and the other members of that family, the network flow problem, they are in fact a type of linear programming problem. So it will be very easy for us to learn about the main type of problem, that is linear programming. In the transportation, the main objective was to minimize the cost, and that we did by reducing the by finding the best route of transportation. But here, we learn about more varieties of problems, not just about transportation, but they will be of many types. It can take any form, provided that they meet certain conditions of linear programming. Okay, so let's start with the history of linear programming. So you would remember that in the transportation, we learned that even though transportation method is a part of linear programming, it was proposed and developed before linear programming was formally introduced. So linear programming was conceived by a person named George B. Dantzig in 1947. And again, it was mainly, related to the defense, the military, and he was trying to find some solution, some method to optimize the planning for training, supplying, and deploying, referred to as programs. So he wanted to optimize the facility, the use of facility that the military had, and these operations like training or supplying or deploying, when he made a plan for them, he called it program. And the most important thing that he found was that these problems which existed in that time, he was focusing on the military, can be formulated as linear inequalities. Linear inequalities, right? So we will shortly, we'll go and learn that term in detail very, very soon. But just for an introduction, we should know, that the main feature of this type of a problem in management science or operations research is that there is a linear relationship and there are linear equations. So that's why it has got the name linear programming. So when George Dantzig introduced this concept, at that time he named it programming in a linear structure. That was the name given to this technique. But later it became more popular by the name of linear programming, and also we call it in short form LPP, the linear programming problem. Okay, so this is a brief introduction to the history, to the background of linear programming, which we should know. And now you can learn, and if you were interested, you can read more on the history, how it developed, right? So that is up to the interest of the students to know as much as possible for a basic concept. Now, where can it be applied, linear programming? Because means generally I used to discuss this example at the end, but I think now, since we have already covered a lot of the background concepts, we can understand this at this point, at the beginning itself, so that we know, where can the linear programming method be applied? How will it help the companies, right? So we understood that it started as in the military. It was basically dealing with the optimization of military facilities. But now, for us, it is important to know how can it be used in business. So, there is an example given in our book, and that is how Amazon used linear programming to improve customer service. So it's a very interesting example. We should know it, and this will give us an idea, and we become more interested to learn this more and more, and we try to understand what is the use of linear programming. Why are we learning this topic? Huh? So let's spend some time on understanding this concept. I will change the color. Okay. So what is this problem? What is this case study in which Amazon used customer service? I don't know if you have studied this from the slide I posted yesterday, but let's quickly read it first, and then we'll do a small discussion. So what does it mean? And this is also very important for us to, it will give us some idea about Amazon. How did it start, and what has it become now? So Amazon.com started as an internet book retailer in 1995, right? So it's a very interesting information. Maybe some of you knew it, and for many it may be a new information that Amazon started with in book retailing, but now it sells everything, isn't it? It sells from A to Z, and that's what its logo says, isn't it? It says, if you look at Amazon, there is an arrow that is from A and pointing towards Z. The idea behind that logo is that Amazon sells everything from A to Z. Okay, so Amazon started with book retailing, selling of books online in 1995. So it's not very old, just around 20 years. After 10 years, it was a Fortune 500 company. You all know what Fortune 500 is? What is Fortune? Anybody knows? What is Fortune? What actually it is? Huh? Okay, the slides are not moving. All right. Okay, anyway, you can find out in the meantime. I am just changing the mode. What is Fortune? Fortune is a very important name. Do you know what it is? Okay, I hope now it will move. Okay, is it moving now? Are the slides moving? Okay, so okay. Now tell me, do you know what is Fortune? No. Fortune is a magazine. It's a Risala. It's a magazine, and it's a very famous magazine for business, like Forbes. So it's a very prominent magazine in the business sector. I'll show you on website of Fortune. See, this is Fortune. You should check these resources, right? Fortune, Forbes, CNBC. These are very important sources for business students because it is not just a local US-based magazine, but it covers everything around the world. What is going on in the business in different industries? So Fortune, it publishes list of 500 top companies in the world, and as we saw, after 10 years after Amazon started, it was one of the Fortune 500 companies. You can imagine, there are so many companies in the world, and out of them, Fortune selects 500 best companies. And you should know on what basis. Okay, we don't have time to discuss that, but as a business student, you should know what criteria Fortune uses to decide whether a magazine is whether a company is in top of 500. But here it's given that its annual sales of Amazon became $7 billion in 2005. So on the basis of that, Amazon was among the top 500 companies of the world in just 10 years after it started as an online book retailer. Now, next it's written, Amazon.com is now a retailer that offers new and used products in variety of categories, including music, video, etc., etc. We all know it. We are very familiar with Amazon. From 2001 to 2003, before it was included in the Fortune 500, Amazon.com achieved the highest score ever. You should note this, okay? This is very important. The highest score ever recorded in service industry by the American Customer Satisfaction Index. This is, this is ACSI, and it's a very important name for us as students to know if we are engaged in mainly in service. Although ACSI gives rating for non-service companies also, but for services, it's very important to know how satisfied our customers are. So here it's a task for you. You can do more research and find out what it is. How does this index rates the companies on service, which are the top companies on the basis of ACSI. Okay, so this index, this rating system called the American Customer Satisfaction Index, it gave the highest score to Amazon.com, which is a very new company, isn't it? It started in 1995, and by 2003, 2001 to 2003, 3 years, Amazon was the highest score receiver by ACSI. So it's a big achievement. Across the world, there are so many companies, and it got the first position. The company's success, why did it become the best in customer service? These are very important points, right? It will give you a broad, dynamics about not just operations research, but we are able to find how it can be applied and how does it help the company overall. So the company's success is partly a result of its strong customer service operations. So here comes, the point of importance or significance for us, that now we are gradually trying to understand how management science could have helped Amazon in becoming the #1 service provider in the world. So the main reason why Amazon became the biggest service provider was because of the strong customer service operations. Customer service is provided through features on the website, telephone, or email. Okay, so these are the three sources or channels by which customer service is provided. So first, let us ask, you all understand customer service? It's very famous. We all have it with customer service. Do you all know what customer service is? Because then only you can understand the example well. So you understand, all of you, what do we mean by customer service? Have you ever seen customer service practically in your life, in any business? So give any example, one or two, where you practically dealt with customer service. Then we can understand how we can apply the same use of operations research of linear programming in locals. Yes, no, that's what I want to know. That what do you understand by customer service? Is it only after sales, or is it before sales, or what? What does it do actually? Customer service is a very important department in, okay, the mobile customer service. Yes, very good. That's a very good example of customer service, as Sahani said. In banks, in restaurants, in mobile companies, these are very famous. Even every company, car companies, any company today, because there is very strong competition, the companies want to retain the customers. Even for small products like Pepsi, if you look at the bottle, you will read, though they don't, they will not advertise regarding customer service because the number of customers is huge. Yes, it's a link between the company and the customers. Even in Pepsi, in the FMCG products, which are low-cost products, even there, if you look at the package, it's written that for any complaint or so you write to this number or email, that is customer service. So, but for service industry like Amazon and telecom, customer service is very, very important. So why is it important? We know at Amazon, why is it so important? Because everything is done online, right? We order online, Amazon processes the order, then it delivers the product to us. Everything is online. So it's very important to ensure that the customer is always satisfied, is always convinced and confident that his money or his, more than money, a person has booked something online, so she wants it, right? If she doesn't get it, it's a waste of time. So that's why customer service is very important in a service company. And one of the examples we are seeing is the e-commerce company like Amazon. So the customer service representatives are available at internally or externally managed contact centers. So here, there is an idea we are getting that Amazon has both internal as well as external contact centers. External means what? They have outsourced. So Amazon doesn't want to spend all their efforts in managing customer service themselves. So what they have done, they have outsourced some customer service. Why have they done? Because that can be done easier or in a much better way. So if somebody is asking some questions, there is a query regarding Amazon service, they might have outsourced it. But some key problems of the customers, they handle it internally. And the customer service works 24 hours a day across the world. So because of its sales growth and seasonality of its sales, seasonality means what? By season. So this may be only limited to USA or the Western market, but now Amazon operates everywhere. So the seasonality will vary from place to place. So because its sales growth and the seasonality of its sales, Amazon must make accurate decisions about the capacity. Here is our main, you know, technical word for what we have learned so far, the capacity of its contact centers, including the number of customer service representatives to hire. So hiring means what? What does it relate to? Hiring, when we hire someone for our company, what happens? It becomes a cost for the company. It is a cost. So that's what we have to do. We have to ensure that our service is best and the cost is minimum. So for that, we want to hire minimum number of people for the best service. So the number of customer service representatives to hire and train at its internally managed centers, and the volume of voice calls and emails to allocate to external service providers, referred to as co-sourcers. So this outsourced facility is called co-sourcers. The service times for calls and emails are categorized depending on the product type, the customer type, and the purchase type. Amazon's objective is to process calls and emails at target service levels for different categories. For voice calls, the target is that a specific percentage of callers wait no more than a specific time. So this is the first output. They want, this is one constraint, that if they want to optimize the cost or optimize the customer service, they have one constraint, that the waiting time for the customer who is calling should not be more than this, because normally you would have experienced that you are calling a bank or mobile company to launch a complaint. There will be an automated message that you have to wait for 1 minute, 2 minutes, and sometimes it is endless. So that becomes a reason for dissatisfaction for the customer. So Amazon said, we will limit the waiting time to certain minimum. So it may be half a minute or 1 minute, so that the customers don't have to wait. So that's one constraint. Then for emails, the target is that a percentage of them receive response within some time period. So every good company, when you write to them, you first get an automated message that we have received your email, and we will assure you that we are going to respond within 24 hours or 48 hours, 2 days or 1 day. So that's another constraint for email. So Amazon uses, now we come to our main point, the Amazon uses linear programming model to optimize its capacity decisions at its customer service contact centers. The approach provides a minimum cost capacity, that is minimum, that provides the number of representatives to hire and train at Amazon's own centers, and the volume of contacts to allocate to each co-sources each week for a given planning horizon. Objective function costs include, so Zmin is equal to number of normal and overtime hours, number of new representatives hired and transferred, and the cost of contacting with co-sourcers. So these all three variables are the decision variables, and they are found using linear programming method to minimize the transportation cost. There are several categories of constraints, okay, related to the number of voice calls and emails, and for normal and overtime hours at both the internally managed contact centers and co-sourcers. For a 1-year, 52-week planning horizon, the linear programming model consists of approximately 134,000 constraints and almost 16,000 variables. So you can imagine we have been learning in transportation and also in linear programming. When we do it manually, we use two or three constants, isn't it? But here you see in practical, the number of constants are 134,000. So here, we need sophisticated, but at the base, we see that there is a Z which has to be minimized, and there are decision variables, and there are subject to constraints. So we come back to the same basic OR model. So this is an application of OR in business, and specifically by the use of the tool that we are learning, that is linear programming. Okay, so this I hope is clear. You read it and try to understand and find, not just understand, but do research and find out more about how much cost is saved, what is the tool they have developed. Okay, so what we learned is that linear programming technique derives its name from the fact that the functional relationships, what is functional relationship? This formula that we like, right? X1 plus X2 or whatever. This relationship in the mathematical model are linear. And the solution technique consists of predetermined mathematical steps, that is a program. So these two are the main features of linear programming. Even in transportation, if you remember, we saw that the relationship is linear, and in order to solve the problem, we have to follow steps. There are various methods, like in transportation also we saw there is WAM and MODI and Northwest, least cost, simplex, okay, and then these are used in the computer programming to solve. Similarly, and simplex is also a method to solve linear programming, so it can be applied to transportation also. So there are many methods, but the basic feature is that there are steps to be followed to solve the problem of linear programming. And that's what makes operations research interesting, that it is all about learning the steps right from the problem formulation till solution. We have to learn how to apply these steps. Only then we can solve. If we make some mistake, as some of the students who sent me the answer, just one mistake and your complete answer may be wrong. So we have to remember the steps very clearly. Okay, so linear programming, you should remember this. Okay, linear programming is a model that consists of linear relationships representing a firm's decision, objective, and resource constraints. So then comes the question, what is linear relationship? What do we mean by linear relationship? Linear relationship means that when we have two variables, like here, there is distance and time, and we are measuring both distance and time. Suppose we are sitting in a car and we are moving, so we are calculating the distance covered and we are calculating the time spent. So we are noting down all the points. So suppose we have started noting. So after 1 kilometer, we spent half an hour. After 2 kilometers, we have spent 1 hour. So what we are doing in a very systematic manner, we are writing down the distance covered and the time spent. Okay, and when we plot these two variables, so you understand these are two variables. Why are they variables? Yes, study the relationship between two variables. But remember, as Belasan has just said, two variables. We should remember that linear relationship can exist between multiple variables also. The problem with human, manual picture is that we cannot plot it on graph paper manually, but computers can do now, isn't it? You understand? What I am saying is that in the picture, that we are just seeing, there is a relationship between just two variables. But in reality, as we just saw in Amazon case or in the transportation problem, we saw one example. It is very much possible in reality that there are many variables, many decision variables. Are you understanding, all of you? So manually, we can maximum at the max, we can use two variables or three variables in writing the constant equation or the objective function. But in practical, in the actual business situation, we just saw customer service problem, and there can be thousands of variables. So when that comes, it was manually not possible earlier, but now it is possible. So we can use the computer programs to model it and then solve using the linear programming method. So that we have already learned in computer solutions. Okay. So, but we should know how does it work? How do we solve it? So we will take two variables. So what we are seeing that there are two variables, distance and time, and as Belasan says, there is a relationship between these two, distance and time. And that relationship, we know that it is speed, Sura. So what we are seeing that this car is moving from, it has started from 0 and it is moving. And when we plot the distance in respect to the time, we put it on the graph. We are getting some points. For example, this is 1 hour, 2 hours. Try to understand the graph very well, because we are going to use graphical solution to solve linear programming problem. Okay. So if you don't understand, just ask me, because we don't have to waste. Next week is your midterm, so we'll continue after the midterm. So don't forget this. Okay. In the graphical solution, we have to plot the two variables on the graph. These are decision variables, T and D. Right now, we are not, in this example, we don't know what decision variable is. And so we have two variables, time and distance, which change, and they are plotted to find the speed. So what we are seeing that when the time is 1 hour, the distance traveled is 25 miles. When the distance time covered is 2 hours, yani you started at 1 p.m. in the noon. At 2 p.m., you reached 25 kilometers. At 3 p.m., you reached 50 kilometers. At 4 p.m., you reached 75. At 5, you reached 100, and so on. You kept on moving till you covered all the 400 or 300 kilometers, 300 miles. But when we put on the graph, we can join these points and get a straight line. We get a straight line. What does this mean, a straight line? Can you tell anyone? What does this represent, a straight line? Any idea? Do you get? By looking at the picture and by looking at the problem, that you started at 1 p.m. and you kept on moving by your car, and you were checking your time and the distance covered. So what does it mean that you are getting a straight line between distance and time? Yeah, that is like linear relationship, but for a layman, if somebody doesn't know, rising, yes, that's good. Rising, but is there any condition in rising? In a positive relationship, good. Tell something more. Is there anything more you are seeing in the rising and positive relationship? That the time is increasing and the distance is also increasing. She is right. If she is Shahad, I don't know, Shuru or Shahad. Yes, sir. Decision variable. Yeah, okay. No, but let's proceed from what these people have said, these students, Tahani and Shuru or Shahad, SH. Yeah, Shahad. So continuous, yeah. So there is a continuous rise in the time and distance. But there is one more thing missing in this. What type of rise it is? Is there any special type of rising increase? It's the time rise and distance rise. That's good. And time is also rising and distance is also rising. Both are rising. But are they rising in a particular fashion, in a manner, because of which we got a straight line? So I just want to probe you too much. I want to see if you can answer this question, and then you'll understand what linear relationship actually means. Let's see. I am sure somebody will. In equal proportion. Very good. MashaAllah. Good. So it means that the distance and time are changing. The rate of change is same. Do you understand? Takayyur. What can we say? Rate is what? Rate in Arabic? Rate of changing. Rate of change. Rate. Muaddal at-taghayyur. You're right. Muaddal at-taghayyur is the same. So what we are seeing that if you look at it from each one, from 0 to 1, how many kilometers? 25. From 1 p.m. 2 p.m. to 3 p.m. Yani when it covered 1 hour more, how many kilometers? How many miles? Again 25. And 2 to 3, how many miles? 25. So are you understanding? Each hour, each 1 hour, the distance traveled is 25 miles. So that means the rate of change is same. So it is moving at a speed of 25 miles per hour throughout. There is no change. And that is why such relationships are called linear relationship, when the rate of change is same, is constant. Rate of change is constant. So this means the relationship between the decision variables is constant. It's moving at an equal proportion, as she had just said. Okay, so I mean, you can listen again to the recording and try to understand. You have to understand this very well, because that's the basic issue or basic feature of linear programming, that the variables have linear relationship between them. So is it clear? You understand what does linear relationship mean by looking at this picture of speed, the relationship between distance and time? Okay, so there are two. If you don't still understand, just tell me. I will repeat again. Okay, then the objective function. What can be linear in linear programming? It may be objective as we write by Z. It may be objective function, or there can be model constraints also, which may be having linear relationship of the decision variables. So there may be either the objective function or the model constraints, both have linear relationships with the decision variables. So this becomes our criteria. So whatever problem we get in linear programming, at our stage we will be told that this is a linear programming problem. In advanced stage, when you become expert, a professional in OR, in management science, you will first check, when you model the problem, you will be able to know that this problem is linear or not. If it is linear, then you will apply the linear programming method. Okay. So can we move forward to the next? Do you want me to revise anything? You understood, all of you? Okay. You understood linear programming, linear relationship? That's the most important thing we have to understand in this chapter and all transportation. Okay. So let's move to the next. So now we come to the same as we learned in transportation. So what is the feature of transportation? Is it also linear? I mean, does it also have linear relationship? Yes, it has linear programming. we learned that transportation method is also all of these three: transportation problem, the transshipment, and the third one was, who will tell? There are three types of network problem. One is transportation, transshipment, and the third one is assignment. Excellent. So all the three types of network flow problem, they are all linear programming. So we can now imagine that there is a linear relationship between the, and that linear relationship means that there is a positive or negative. It can be positive and negative both. The change can be negative also. That you increase the cost or you increase the price and the quality is going down, or the cost is going down, or the sales demand is going down. So then it becomes a negative relationship. But the condition for using linear programming method is that it must be linear. It should be changing at the same rate. So it may be going up or down, doesn't matter, but the change should be constant. Okay. So when we come to create the model for linear programming, as we have done already, we will get the following components. There will be decision variables, there is an objective function, and there are model constraints. So, I mean, this is not to be explained any further. We have spent a lot of time on this. Okay, but I'll just check. So, Z min, what is this called? I mean, just for checking, so that I check whether you are prepared for midterm or not. Z min or max. This is which of these three? Is it a decision variable, the name of decision variable, or objective, or constant? Very good. So this is objective. Then we in transportation we said the demand at market D1 is 400 units. So what is this? Is this a decision variable or objective or constant? Very good. So you are very smart now. We don't need to spend too much time on it. Just try to revise for your midterm. Though this chapter is not coming, and even the transportation, but the previous chapters we have done this in model formulation. So you have to revise. So this model of linear programming also will have the same components: decision variables, objective, and the constraints. Now we are coming to linear programming solution, how to solve. So there are three steps in solving. This is from the book, so you can check the chapter, linear programming, modeling, and graphical solution. That chapter full, we are covering that chapter. So steps in applying the linear programming technique. First, the problem must be identified as being solvable by linear programming. So here, for us, the problems that we'll get, they'll be like in the transportation, we said it's a balanced problem. So we will get balanced problem, we'll just check whether it is balanced or not. In the case of linear programming problems also, the first criteria is to check whether it is solvable by linear programming or not. That means the variables are having linear relationship or not. So that's the first. Second is the unstructured problem must be formulated as a mathematical model. This is what we have to do, as we did in the transportation, that we have to write the equations. Z min is equal to this, and subject to constant number 1, number 2. And then finally, the model must be solved by using established mathematical techniques. It may be graphical solution, or it may be simplex method, or you use Excel solver, whatever, so we learn to solve the problem once it has been formulated. That's what we have to do. So these are the three main steps in solving the. Now let's look for an example, an illustration, not a formal example. It's given in the book. An electrical, listen carefully, okay, now, because we are now coming to the modeling, creating the model. We still have time. We'll try to cover both. If we miss something, we'll take it in the next class. An electrical manufacturing firm desires to produce radios, toasters, clocks. So this is the problem, starting from telling that there are products to be produced, where and are symbols representing unknown variable quantities of each item. I think this is missing. Let's say R and T and C. These are the numbers of 3 items to be produced, R, T and C: radios, toasters and clocks. The final values of dash and dash, I think it's checked from the book, as determined by the firm, constitute a decision. Example, the equation radios is a decision by the firm to produce 100 radios. So Z is equal to R plus T plus C, and there is a subject to, there will be some constraints to produce it. And why will the company decide to produce radio or toasters or clocks? The main reason will be to maximize the profit. So from R, there will be a profit, some profit, say 10 from selling 1 unit. From toasters, there will be a profit. From clocks, there will be some profit, say 2 reals. Now this becomes our equation, 10R plus 15D plus 2C, and the company has to decide what should be the value of each of them to produce, so that the value is maximized, so that the profit is maximized. That becomes the main question. So this is an illustration. Now let's come to a proper example from the book, for the example of maximization. Linear programming can solve both examples, maximization as well as minimization. So the first example is of maximization, and the main theme of this problem is to maximize the profit. And this type of a problem, as we just saw in the previous one, the company has to decide which item to produce more, radio or television or toasters or clocks, because all of them give different levels of profit. If I sell 1 radio, they get 10 reals of profit. If they sell 1 toaster, they get 15 reals of profit. If they sell 1 clock, they get only 2 reals of profit. But given the constraints, which item should be produced in what quantity, so that the product, the total profit is maximized. This type of a problem name is product mix problem type. Okay, so this is called product mix problem type, which in the last week we saw, in the last lecture we saw about the transportation from demand center to the supply center to minimize the cost. So that is the name, transportation problem, the network flow problem. It is also a linear programming problem. So let's look at the problem now. Beaver Creek Pottery Company is a small crafts operation run by a Native American tribal council. The company employs skilled artisans and labor to produce clay bowls and mugs. So this company has 2 products. One is the clay bowls and the other is mug. Got it? So this is the first information. We are trying to take out all possible information, as we learned in the steps of management science problem solving, problem definition and formulation. So we are trying to take out all quantifiable items or information from the problem, so that we can then formulate and create the model. So they have two items. One is the clay bowls and mugs with authentic native American designs and colors. The two primary resources. Now comes the constraint side. Okay, so this is first information. Then they are telling about the constraint now. The two, that means resource. So they're talking about two resources. One is the clay, special pottery clay. Clay, you understand? Clay, I mean soil, which is mud or soil, which is wet, which is used to make crockery utensils. I'll just tell you the Arabic for clay. What is it called in Arabic? And if you know, just make it, write it there, because we should know what it is, this resource. Okay, so it is called fakhar. Is it the right word? Teen or fakhar? Teen or fakhar. So this is the first main item. It's written as per Google Translate. It is teen or fakhar. Okay, so this is the first resource. The second resource is labor. Labor. This is like there are not many people who can make this. So they need human beings who labor to make this product. So these are the two constraints. Constraint number one, constraint number two. Two products, the clay bowls and mugs. Given these limited resources, these are limited resources. They are not, every company has limit. So this company also has a limit. So within the limited resources, the company wants to know what is the number of clay bowls and mugs to produce in order to maximize the profit. So, I mean, the question is very clear now. So, one thing that we can immediately write is Z. What should we write? Z is max or min. And Z stands for what? Max. Z stands for profit. So, in this problem, we have Z, max, and the decision variables are C and M. Constraints are clay and labor, but we have to know more details. More details are, that means the parameters are still to be found. So let's go to the next detail. So what we do, first of all, we define, these steps are all given in the book. Okay, so you have to try to read it from the book, otherwise follow the video lecture and the slides. But if you read from the book, it will become much clearer. So step number one is how many bowls and mugs to produce. That is the definition of the decision variable. Objective function is maximizing the profit. Constraints are what? The resources available. So we know all these. Now we just need to know the parameters. So that problem is given in picture form in the book. What is given? It's given here that this is the clay which is available. Okay, and these are labor. These three are labor, people working. These are two products, final finished products, mugs and bowls. So what do we see here? One thing given is 120 pounds per day. Who will tell what does it mean? Just explain. Don't write anything. Just tell. In word form, you can write the answer, but I don't want equation. Just tell me, what do you understand by clay equals 120 pounds per day? What does it mean? Fast, quick. And if you were, okay, only can use 20. Oh, very good. Yeah. No, how much? No, no. The first one is right. I don't know her name. She is right. The second one, you need to just correct a few things. How much clay they need per day? No. How much clay they have per day? Okay, so you just correct it now and write again. Lamia. First one, yeah. So just correct it and write again. Lamia, how much clay they need per day is not right. How much clay they have per day? Okay, right? So it's not up to them, to decide how. I mean, they want to use 200 or 300. No. Okay, so they have per day. So they have 120 pounds clay available in one day. Now they have to produce mug or bowl. They will have to use 120 only. They cannot take more than that. Even though if they want, they cannot. So that is first constant, the constant of clay. The second, I think now should be clear to you that the labor, which is available to them, the company, is 40 hours per day. So these three people, these three together can work for 40 hours per day. So that's another constraint. You cannot make them work more than 40 in one day. So this is the constraint. Now look here. Who will tell what does it mean? Mug $50 and bowl $40. Do you get any feeling, any idea? What does it mean? Let's see if you understood. Price. Price of what? Look at the entire thing. This entire. Pelesan says it's price. Anything else? Cost. Okay. Look at this. These are, information given to us to solve the problem. So we have to pick from the information given. We cannot make anything. So these are parameters given to us. The company tells that, see, this is 50, this is 40, and it's given here. Now, one person said price, the other said cost. Any third opinion on this? Cost for each piece. Okay, now she is coming close. Cost for each piece. Okay, so let's wait and see if something more can come. So Tahani said cost for each piece. Mug costs $50 and bowl costs $40. But if you look at the problem, it is written here profit. So just a minor correction. No. A minor correction here that these 50 and 40 are the profit received by selling one mug and one bowl. So if I sell one mug, I get a profit of $50. And if I sell one bowl, I get a profit of $40. This is my parameter for decision variable. So now I say suppose mug is x1 and bowl quantity is x2. Okay, so we'll have to give a name to the variable. So this variable, this is the main decision variable. What is it? Who will tell? What is the main decision variable? How many mugs and bowls? Let's go back to the question. How many, here see, this is the main decision question. How many bowls and mugs? So let's say bowl is x1 and mugs are x2. So x1 and x2. Now the question is, Z is what? Z is max. That is maximization. How will we get the formula for profit? This is profit max. We'll have to find the profit of by selling mug and profit by selling bowls. So X1 is the number of mugs and X2 is the number of bowls. If I sell X1 mug, what is the profit by selling one mug? What is the profit by selling one mug? 50. So if I sell X1 mugs, $50 multiplied by X1 is the profit I make by selling mugs. How many mugs? X1 mugs. So this is one, and I don't know now, I have to find this. This is the decision variable. Similarly, X2 is the number of bowls I make. By selling one bowl, I make $40. So by selling X2 number of mugs, I make 40 multiplied by X2 mugs. So this is 40. So what is this? This is the profit, total profit. And what are we supposed to do? We have to maximize this profit. How? Two constants are there. Okay, two constants are there. One is regarding the mug and other is regarding the bowl. So let's see, X1 is the number of mugs and X2 is the number of bowls. The problem is, if I say, the clay, how much clay is required for making X1? I don't know. How much clay is required for making X2? I don't know right now. Till now, I don't know. Then we come to the labor. How many labor are required for making X1 of mugs, bowls, and how many we need for bowls? We don't know. Okay, so but it's given in the example. So this is the only information we need more. We have already formulated the maximization, the objective equation. So objective equation is clear to all. Okay, Z max is equal to 50 is the per unit profit multiplied by X1 plus 40 is the per unit profit multiplied by X2. Clear? Okay, so let's go to the next slide. This is the complete information given regarding the profits. We already know 40 and 50 is given, but these are more parameters given. Labor. So it's given that 1 hour is required. 1 hour is required for making one bowl. Okay, one bowl we need 1 hour. For making one bowl, we need 1 hour. So for making X1 bowl, we need 1 into X1. And mug is X2. So for making one mug, it needs 2 hours. So for making X2 mugs, it requires 2 into X2. Similarly, for clay constraint, clay resource, for making one bowl, 4 pounds are required. And for making one mug, 3 pounds are required. So if we make X1 bowl, we get 4X1 clay is required. For making X2 mugs, 3X2 clay is required. Okay, so we got that information which was missing here. These were the two equations for constraints, and we had to find what is the value of this question marks, and we have got this. So we can write here, we'll write it here. For constraint of clay, first of all, we'll write for labor. Okay. So labor is 1x1 plus, tell me, what should we write for labor? 2x2. 2x2. This is the total labor required for making x1 and x2. You're getting? Okay. This is the total labor required for making x1 and x2 combined. So I am going to produce mugs or bowls. When I add them together, this is the total labor requirement. But what is the constant? Who will tell? What is the constraint for labor? This is the total labor which will to make x1 and x2 together. What is the constraint of labor which will complete this equation? It has to be, yeah, very good. It has to be less than or equal to 40 hours. It can't be more than 40. So if you understood that, Belasan is right and Najwa, Razan and Abrar. Good, very good. So other students, can you tell me the equation for constant number 2, that is clay? First of all, let's write what is the total. Yeah, okay, very good. 4x1 is the total clay required for making x1, that is bowl, and 3x2 is the total clay required, total pounds of clay required for making mugs. So this is total clay, 4x1 plus 3x2. But what is the constant again here? There is a question. Yes, very good. It has to be less than or equal to 120, and this is in pounds. This is in pounds, total pounds. So now we have Z max. Why? Because let's look at here, this picture. Labor, the company has a clay lump, the company has 120 pounds. So I make x1 mug, I make x2 bowls. Total should be 120. But how many pounds of clay are required for making x1? 1. How many pounds of clay are required for making 4? 4 pounds. And here it is 3 pounds. So this total, 4x1 plus 3x2, this is the amount of clay, total amount of clay required for making x1, mugs and bowls together. So mugs and balls together, we need 4x1 plus 3x2. But how much is available? 120 pounds. So that's why, we have to write the constraint equation as 4x1 plus 3x2 has to be less than or equal to 120 pounds. And for labor, 1x1 plus 2x2 must be less than or equal to 40 hours. Now the equations are all ready. So we have all the equations ready. Maximize is Z is equal to 40x1 plus 50x2. Why are we writing plus on both? Because it is possible in any problem that there may be a loss also from selling a product. It's possible. Anything is possible. So we are not looking at it from the business point, but from management science problem. Somebody is giving us a data information and it has a negative, so we can easily write negative function also. No issues. Okay, so Z max we have got. Then we have already written this. This is 40 of labor, 120 of clay. This is labor. This is clay, and the last is that x1 and x2 must be 0 or greater than 0. It can't be negative. Okay, it cannot be negative. So these are the model constants. And finally, the complete model is maximize Z is equal to 40x1 plus 50x2 subject to 1x1 plus 2x2, and these are the constants. So I think this is enough. We'll just understand the maximization problem today, and in the next class we'll first do the minimization. So Tala is clear regarding the formulation of the model. All the students are clear now how we got the 3 equations. Very easy, just okay. So once we are able to make this equation, we can then go to the problem solving. So next week after the midterm, we'll solve this using graphical method, and very interesting, again, like transportation, very interesting method. So we have to just follow the steps and we'll be able to find. So what are we going to find? What is the main information we have to find to solve? With this we'll stop. Who will tell in this problem what is the main information to be found by using OR? Once we are able to find that, our problem, no, Z max is not the main information to be found. That is the result. But what is the main information to be found? Tell me. Profit? No. Think properly. You know, look at the question. It's given in the question itself. No. Very good. Yes, Razan is right. Look what she has written. The main variable that we have to find is how many mugs and bowls we are going to produce. Okay. Yeah, x1 and x2. Good. x1 and x2. This is what we have to find. Once we are able to, we are able to find these numbers, and these numbers will be optimal. Why? Because we have taken into account the constraints. So we know that x1 means confirming both 40 and 120. x2 also confirming both 40 and 120. So we have to apply linear programming method to solve this problem, and this problem will be feasible. Solution will be feasible because all the constraints are satisfied, and we will do that after the midterm exam, inshallah. So I can stop now, inshallah, and okay, minimization example we will do next time. Okay, so any more questions? Right? So if no, then I can stop the recording.